morning to my examiner, Dr. Maya, my supervisor, Dr. Tay Mengguan, and also my friends. So today I'm going to talk about the investigation on the production of hydrogen gas from photocatalytic fuel cell (PFC) in a synthetic dye wastewater. So what is PFC? PFC is the integration between two emerging technologies, which is the photocatalysis and also the fuel cell. It is being used to degrade wastewater, at the same time produce electricity and also generate hydrogen gas. The key component in the PFC system is the photoanode, the aqueous medium, and also light source, and the cathode. As we all know, the electricity demand of the world has been increasing years by years. And we're burning the fossil fuels for us to generate the electricity. However, the years of the fossil fuel left for us has been decreasing. As we can see here, the coal is left about 114 years, the natural gas is 52 years, and also the oil is 50 years. Therefore, it is proven that the fossil fuels are unsustainable. Fortunately, the PFC system are able to produce electricity from the wastewater and also generate hydrogen gas, whereby the hydrogen gas can be further used into the fuel cell to provide electricity. Since the research on dual chamber PFC has not been done, the hydrogen gas production in both chambers has not been observed. The degradation of organic-based wastewater and power generation has yet to be discovered as well. Therefore, in this project, my objective is to detect if hydrogen is present in both chambers and to determine whether the wastewater degradation efficiency and power generation in dual chamber is related to the presence of hydrogen gas. There is a lot of ways to produce hydrogen gas. Don't be mistaken by the color of the hydrogen. It doesn't mean that the hydrogen has the color, but it's actually illustrating how the hydrogen is being produced. For the gray hydrogen, it is actually the coal gasification and also the steam methane reforming method without the CCUS. For the blue hydrogen, however, it is similar to the gray hydrogen, just that it's implementing the CCUS, which is the carbon capture, storage, utilization, which means that the carbon being released will be captured and stored into a suitable place. For the turquoise hydrogen, however, it is the thermal splitting of the methane, whereby the methane gas will be decomposed into hydrogen gas and also solid carbon. For the green hydrogen, it is the hydrogen gas production from water using electrolysis through the electricity generated from renewable sources. So the PFC is actually part of the green hydrogen. So now we're moving forward to the principles of PFC, which is the photo excitation. Firstly, the light source, when radiating the photoanode, and enough energy is being given to the photoanode, and it actually needs to have equal or more energy than the energy band gap. The energy band gap is from the valence band to the conduction band. When enough energy is being given, the photoexcited charge will occur, whereby the photoexcited electron will be promoted from valence band to the conduction band. When this occurs, photo-generated holes will produce, and also photoexcited electron will produce as well. So now we need to know, how does the wastewater be degraded? The wastewater is going to be degraded by using these photo-generated holes. The photo-generated holes will react with the water and produce hydroxyl radicals. And also the photoexcited electron will react with the oxygen surrounding it to produce peroxide radicals. Both of these radicals will degrade the wastewater in the chamber. So what about the electricity generation? The electricity generation is through the mass electron transfer harvesting, whereby the photoexcited electron will travel to the external circuit and then produce the electricity. For the hydrogen gas production, however, is that the photoexcited electron will also react with the hydrogen ion to produce hydrogen gas. So there's two conditions that is very important in this PFC configuration, which is the presence of oxygen and also the pH conditions. These two is related closely as the presence of oxygen, if there is oxygen present in the configuration and the pH condition is neutral or acidic, it will produce water and also hydrogen peroxide. And then the hydrogen peroxide will further decompose to become the hydroxyl radicals again. However, if we have this pH condition in basic, then it will produce the OH negative, the hydroxide ion. If the presence of oxygen is absent, and then the pH condition is neutral or acidic, then the photoexcited electron will then react with the hydrogen ion to produce hydrogen gas. But if it is basic, then it will react and then produce hydroxide ion and also hydrogen gas as well. So the best condition is to have the oxygen absence and also the pH condition neutral and acidic. Neutral or acidic. So for my methodology, I will be preparing my photoanode through the electron chemical deposition method, whereby I will cut the zinc plate into the desired dimension, and then I will put it into the solution of zinc acetate with potassium chloride. And then I will have the zinc oxide to pour onto the zinc plate. After it has been potted, I will rinse it with water, with the distilled water, and then place it into the oven to dry it. After it has been dried and cooled to room temperature, I will test the characterization method using the field emission scanning electron machine to see the morphology and also the structure. Okay, so this will be my dual chamber PFC setup. For the switch, it's actually for me to see the degradation efficiency, and then the resistance box and the voltmeter is for me to see the power generation, and these two tubes is for me to test the presence of the hydrogen gas. Okay, so how do I know whether the power generation is good or bad? So I will plot the graph of power density as the current density so that I can see at which point the power is maximum. And then I will test the hydrogen gas presence using the splitter, and then if there is hydrogen, then it will pop the sound, and then you know there is hydrogen inside. For the degradation efficiency, I will be using the UV visible spectral photometer, and then to plot the calibration graph, and then see how it's going, how the degradation is going. Okay, so I will be optimizing for the detection of the hydrogen gas production, whereby I will change the initial pH from 3 to 4 to 5, and then the methyl red concentration will also be changing for 10, 15, 20, and 25. This methyl red concentration is actually my wastewater in this PFC configuration, and also the sodium hydroxide concentration 1 to 5, 250, and 375. From this project, it is to be expected that the hydrogen gas will be produced in both chambers. The dual chamber PFC can degrade organic wastewater and generate electricity, which proves that these two degradation efficiency and the generation of electricity will related to this hydrogen gas production. This is my work schedule. That's all from me.
Okay, thank you.